Okay. So, hi, my name is Krasiński-Sroka, and I'll be speaking about optimizing Flutter applications with respect to speed. So the speed, the visual refresh, that's why it's called 60 FPS, which is 60 frames per second, or bust. So first of all, I'm gonna do this. Hi. I come from Wrocław, a city in Poland, a beautiful city. I invite you all if you have time. There are direct flights a couple of times a day. I work for a company over there called Stack that sponsored me coming here. So we do mostly React Native, but also some Flutter. And I'm a lead Flutter developer over there. Let's go with the topic. Why 60 frames per second? Let's explore where did this come from. In the beginning, we had a very low frame rate. So the first movies were about 20 frames per second, sometimes less, sometimes more, until I think in 1910s, the film industry settled for 24 frames per second as the industry standard that they will produce film for, and the projectors and all the equipment for. Unfortunately, then came the television, and unfortunately for the movies, because with television that was connected to mains came different frequency. Mains had a frequency of either 50 or 60 hertz, and it was natural for TVs to use the same frequency of refresh. So whenever you see a movie, especially like an old movie transmitted in analog way on a telly, it needed to be adapted to the different frame rate, and there are a couple of nice artifacts that happened over time when people tried to move movies to television. I'm not going to discuss this. And essentially this is why we have 60 frames per second as a target right now, because this got preserved into the digital screens of our computers, monitors, mobile devices, and so on. Some people will say, hey, I thought 60 frames per second is basically what human eye can see. This is not entirely true. So from some research, it showed that people actually can see, some people at least, can see as little with as little delay as 13 milliseconds. So 60 frames per second is about 16 milliseconds of delay in between screens. And 13 milliseconds translates to about 77 frames per second. So when you see actually new devices coming, there are several new devices, especially for the gaming market, that say, well, we have 120 frames per second. This could improve something, but it would be barely noticeable for average person that something changes. But let's say it's not totally idiotic idea to buy 120 hertz screens or produce them. And Flutter aims to actually do this. Flutter aims to say, okay, if we have a device that does 60 frames per second, we're going to be able to display your screen or display your app in that speed. And if you have a application that does 120 frames per second, on a device that does 120 frames per second, we should be able to do that as well. And of course, Flutter could do this. It's only we that stand in the way. And to know why is it so, I'll need to describe a little bit how Flutter works. This might be a little too advanced for people who don't know Flutter at all, but if there's something really confusing, just let me know, and I'll try to explain it in simpler words. Flutter is like an onion, and that means it has different layers. The basic layer that most of the Flutter developers interact with are widgets. But there are other layers. Underneath the widgets there are elements, underneath elements, there are render objects. And in the end, we have engine actually running, on our devices that ties directly to the GPUs of our devices. And all these layers have certain responsibilities. And with these certain responsibilities comes certain ways to trip your app over. Let's start with widgets. Widgets are also known in the documentation of Flutter and other places as a configuration. This is really important because whenever we write Flutter code, we basically interact with widgets and we say, oh, we just create a widget tree. This widget encapsulates another widget, encapsulates another one. And it doesn't really translate directly into what happens on the device later. So widgets are basically configuration of what you are going to see. They don't provide any direct connection to the rendering mechanism. What we need to get closer to that rendering phase are elements. And elements are specific instantiations of widgets. So if we use a widget and we actually run an app and it's from a root of our application to some point there is a widget, it would get translated into an element. Some of these elements contain render objects. And render objects are actually the thing interacting with the canvas of the paint layer of our engines. So this is, on the Flutter side, this is basically the last step before we go into C++ engine of Flutter that runs and that actually executes commands on GPUs. And in the end, yeah, engine produces an actual house. And there are several steps that start with the widget and end with the actual objects rendered on GPU. The first of this is translation of widget to an element, and this is done in a couple of different ways, but usually it's create element, and with a stateless widget, the widget that doesn't have a state attached. This is a very simple translation. We translate that to stateless element. With a stateful widget that has a state object attached, we translate that to stateful element that has the same state attached to it. And you need to remember that there can be one widget, actually, one instance of a widget class that ties to many different elements, because elements are specific instantiations of these widgets. And with stateful widget, we have as many instantiations of a state object. So that's why when you write a stateful widget that's detached from the state object that actually does all the heavy lifting and work and building of other widgets. So we translate this to a separate object that gets tied to the element. And then elements translate to render objects. So as we know, in Flutter we have this, let's say, tree of widgets that we create, we write as developers. These get translated to tree of elements. And there are two main types of elements in Flutter. There's a composite element, but element that actually doesn't render anything, but it has children that might render things. So this basically is what, whenever you write a stateful or stateless widget, this is actually a composite element. But some widgets are tied to the render object element, or actually subclasses of render object elements. So many of the widgets provided by the Flutter framework are tied to the render object element. And in the end, these render object elements will tie to render objects. And this tree of elements will always end with a subclass of render element. So on the leaf side, there will be always render object element. Okay. more render object elements. That was the duplicate slide. Okay, and where does this render object come from is actually a little bit counterintuitive, because we think, okay, so we get closer to the rendering layer. So on a very most humane abstraction, we have widgets, and then we have render objects. But actually, these render objects are created again by widgets. So there's a specific class of widgets called render object widget, and its subclasses that create render objects. It is done so that actually you don't need to write several different classes, let's say widget, elements, render objects. You just write a widget, and that should be most of it, and the rest should be a matter of engine that takes your widgets and elements and objects and translates them into whatever they need to do on the different layers of the framework. Okay, and that's basically how it translates one to another. Of course, all right, so there are two methods there, like I said, render object widget creates a render object, and this again gets attached to render object element. It's actually that render object element does most of the work, or actually all the elements do most of the work. The widgets are the, like I said, configuration. We write it once, but they don't do lots of framework logic, and render objects responsibility is to paint. So they don't really do a lot of logic in between different objects. They should be quite simple. And I'll explain later what they do. But let's start with the top level change. So we have stateful widgets. So whenever we write an application that wants to change, we write stateful widget. And with this stateful widget, there is a set state method that we use to update things. Like we say, hey, we increase the count of something, or I don't know, the image from a network came, so we need to set state with that new image. But set state is unfortunately a bad name, because it doesn't set any state. It marks this stateful rebuild. Okay, yeah. I needed to see what's next, because unfortunately with Zoom I cannot see the next slides here. And this happens on all the layers, but we don't actually set any state really. The set state means, hey, this stateful widget needs to be rebuilt. And it goes on a queue of widgets that need to be rebuilt, basically. Similar things happen with elements and with render objects. They don't synchronously update themselves. They don't do that as soon as possible. They go on a list of dirty elements, and every 16 milliseconds, Flutter tries to clean these dirty elements. So it goes over first widgets, then elements. I said elements too much. Flutter tries to clean all the objects that it has. So first goes to widgets, tries, hey, I have these dirty widgets, I need to clean them up. I'm cleaning them up by doing updating the state, and I'll tell you a little bit more on how it happens, and does so with elements and does so with render objects. So when the widget changes, the underlying element does a perform rebuild. So eventually we clean the widget, and what it does is I'm doing perform rebuild. What does perform rebuild do is it looks at the new state, the old state, compares them and says, well, how can I tie them together? Is it, actually when you look at the stateful widgets, and unless they do either of these things, like they can reuse the old element, which is basically checking, hey, this runtime type of my widget is the same and the associated key is the same, I can reuse that element. Or maybe there's a global key associated with that element, and that means that there was somewhere a widget containing the same key, and I can take it over and just adapt to my tree. Otherwise, if this isn't satisfied, we'll have a new instance of state going on, and it is going to be a little bit more heavy on the engine side. So when we have this tree of elements, the first part is really important. Like, I'm going through this element, goes through its children and says, hey, can I reuse them? And the point is, like, if we, this is one important point that I'll illustrate later. If we introduce like different widgets conditionally in the tree, like for example, on every third click, we add opacity widget in between, it might actually mess up all our logic beyond this opacity widget, because it's going to not match. Like, there will be this new widget that's totally different runtime type and definitely not the key I want. And from then on, everything will need to be rebuilt. Okay. And if an element gets rebuilt, either gets updated or is fresh, the render object underlying it will also mark itself as a layout. That means, hey, I'm going to be dirty. Okay, it's not mine, is it?
I don't know, it's also.
Okay, yeah, and when this, okay, so before we had these component elements, when we write our elements, this happens like that. When we have render object elements, the leaf elements of our application, we do mark needs layout on the matching render object. That means we go and say, hey, on a queue of dirty render objects, I'm going to put this one, like the one I'm associated with. And then render object performs a layout. What it means is basically from a root widget, we go and take the constraints of a root widget. So a root widget is basically my application, and it says, well, these are the constraints of my app. I have this wide application, this high screen, and I'm going to apply these constraints to the render object on the root. Let's say the topmost render object. What may then follow and say, okay, so I'm a render object that lets my children render only on a half of the size of a screen. So I'm shortening the constraints and I'm putting that into my children. And basically, if any of these things change, so actually the first thing is, if the render object has been explicitly said, hey, you need to do a layout, it's going to. If the constraints change, so let's say we on the two passes of these of a render object relayout, the constraints that were given to me previously to this render object, the new constraints are different. I'm going to change. And the third thing is what's called relayout boundary. And relayout boundary means that there are certain points in a render object tree that said, okay, don't look further. And there are certain conditions. I'm not going to go into the details on them, but certain widgets are more beneficial to us because they can actually block doing layout on a huge scale. They say, I'm the boundary of when you actually need to touch. Okay, and the last thing that actually gets did is a paint. So when a render object needs to repaint itself on a canvas, like for example, its colors changed because it decided that the state somewhere has now a different property, and I need to draw on a canvas a totally new color. This happens. However, this is not part of a real of a framework element. The render objects themselves decide when they want to repaint. So this doesn't really happen at a certain points in an application lifetime, or there is nothing to trigger this mark needs paint than explicit code in one of the implementations of render objects. Okay, that was quite a run through the theory of it. Let's go to how do we actually optimize the apps. So Flutter provides us with 3 different ways of running our app. These are debug, release, and profile builds. And if you think you have a problem with your app, first go with the release build. The debug build that you get during development, it does very unoptimal things. It provides lots of assertions and checks on a scale that are really slowing down, for example, your animations or slowing down your application. And this happens quite often that you see, when I'm developing my application, it goes really slow. But then when I switch to the release build, I don't see any problems. So go with the release build. If a problem doesn't exist over there is no problem. Second, if there is a problem, try to figure out what's happening. So try to actually do the debug build and examine what's happening. There are certain flags that can help you, and I'll show you a little bit how you can use them in the debug builds. And the third thing is that if you have some slight performance problems that you cannot tie to, like for example, me doing set state on every frame on a root widget that basically makes all the widgets rebuild every time. Go for a profile build, which is very similar to the release build, but it actually lets you tie down to some metrics of a profiling, and I'll show you how these metrics look like. So if you go for a debug build, like there's a problem, try one of these fields. So these are quite long names, and I always forget what they are named. So these start with debug print something, and all the nice fields that let you debug things are starting with debug print something. This will let you inspect how often do you do things. Maybe there's, for example, a task that runs when your application is idle. It rebuilds your widget over time, and you don't see it, for example, because it's the same widget over time, but since it does a rebuild, it smashes your GPU. The same goes for layout and paint marks. If you suspect something's fishy with either of these steps, you go and try enable these flags, and maybe it's going to help. There's also one nifty tool called Repaint Rainbow. I'll show it to you in a minute. You can actually enable this from your extensions. If you have IDE with a Flutter extension, this should support it, and also Dart DevTools, which are your friend, and I'll show you exactly how much they are friendly. Dart DevTools have been introduced several months ago, and they are basically awesome in terms of debugging, because you don't really need to set all these flags and inspect your console for whatever wrong happens. Dart DevTools do that for you. And I'm going to switch to my mobile. First my desktop to show you how these look. I need to change the screen. It's going to take a while. 30 seconds.
It's not 65 percent.
It's definitely, I can tell you what's happening right now. Oh, seems like there will be something. Okay. Huh. So I have an application that you cannot really see from here. I'll show later what it does. And when I launch in debug mode, I'm reaching these Dart DevTools. Yeah. Oh, by the way, I didn't say this. If you don't have an IDE that supports running DevTools straight away from your extension, use these commands, and you should be good to go. So Dart DevTools. This lets you inspect all the things in your application, like all the widgets. Let's say, well, at the root, there's a root widget. It has a render object. I don't know if people in the back row can actually see any of this. That's better. Yes, that's a root. It has actually a render object attached. It has a debug mode enabled, some size, that's the constraints basically, configuration and so on. And my app, that I'm not going to show you right now yet, is composed of this tree of widgets. Some of them have nifty icons, some of them don't. Okay, and this is my app. I can toggle several things from here. I can show I want show performance overlay because it's always on. But I can toggle different things over here that you won't see from this distance because Zoom cannot allow me, but they help you with debugging all of your applications. And it includes also disabling the debug mode banner, which if you want to display something that you haven't built in release mode to the client, it's very awesome. I recommend. And there's also Repaint Rainbow. And Repaint Rainbow will actually help you investigate when things repaint. It shows borders around elements that are being rebuilt. And every frame it gets rebuilt, they change their color. So that's why it's called rainbow, because they progress to all the colors over time if they are getting rebuilt. If you have an animation that runs over time, there will be like a huge rainbow around the element that has that animation. There's also a nice clock saying enable slow animations. So if you feel like there's something here.
Have you had a problem that something rebuilds so frequently that the rainbow is invisible, like you don't see this colors changing because it's getting rebuilt so frequently?
Usually, I think if that happens, I basically cannot even launch the application because it's so slow then.
Okay.
You can do things like this. You can, like, in your build method, you can set, I'm going to, in the next frame, please dirty me all the time. Doesn't matter what I do. But no, I haven't met that. I don't know where the problem is before I went into the debug, into the rainbow mode. So actually, I also don't use the rainbow so often because when I debug, I do console log and debug print. I'm this kind of person that doesn't use debug tools most of the time. and then stares at the console and scrolls through pages and pages until they identify what's wrong. So I don't use the rainbow that often. I use it sometimes to actually display, to show somebody, hey, that's nifty rainbow. But yeah, I use sometimes, this is a button called debug paint to see where in my application, it's still small. If you come close, all of you, you can see where the borders of my elements are, and the baselines of my text elements that somehow go in the wrong direction. So this is my application. I can refresh this tree if something changed. So that's DevTools. DevTools can also show you performance overlay. Yeah. So if you run it in debug mode, it will actually tell you are running your app in debug mode. Yes, debug mode frame rendering times are not indicative of release performance. So basically run with a profile and try again. So I'll try to run this with my in a profile mode, and I'll switch to showing. First I'll show the I'll show you the DevTools, how the profile mode looks like, and then I'll show you what's on my mobile. Now it's going to build a profile build of my app. Just going to take a little while. I could say a joke, but I don't know any. Oh, by the way, I'm going to upgrade this presentation, and if you are on DroidCon in Berlin next month, I'll be there showing it to a larger group of people. It terrifies me. It's 1,200 people over there, seriously. But I've told some of the guys before, I've seen like so bad presentations in my past, like I cannot do worse, seriously.
So time for a question?
Yeah, every time.
Is there a way from Dart to WebAssembly? Does anybody know about that?
There could be, because basically Flutter gets compiled to native code, and I guess you could compile it down to WebAssembly. Although the problem would be how to integrate with the rest of the system then, right?
That's not an issue. That can be done.
That could be done.
I think it means that the rest of the system being Flutter itself.
Yeah, I mean the framework itself.
Both ways, from Flutter to WebAssembly, and having it as what you are doing in the next session. I'm sorry, I'm not here anymore at that time. But to have both ways to integrate Flutter into other environments or other environments into Flutter.
There's certainly a way. It is doable, and people do that. So we have both desktop applications on Flutter and web applications now with Flutter that basically this got announced as a beta beginning of May on
It's
Google
not
I/O.
about any way of the target. It's just a question of having interfaces to WebAssembly, because you have so many inputs you can get for WebAssembly. So that would be nice to have to integrate more projects with different languages, with different environments to WebAssembly.
But Dart doesn't compile to WebAssembly at the moment. It doesn't compile to WebAssembly.
There's no inscription available.
No, it's by the standard.
Okay.
You could compile it to JavaScript, which compiles to WebAssembly.
Yeah, but
They're completely
that's
insane.
possible.
But it's about rendering stuff, so if you cannot render things, what's the point? Right?
What kind of rendering do you need?
I mean, Flutter is there and written in Dart to render things in OpenGL. So you would need a mechanism to like compile Flutter or Dart code to WebAssembly and render in OpenGL in the browser.
So that can be done.
Yeah, technically yes. But
Yes.
I think they're working on
Rasi
it.
will do that.
What?
Rasi.
Basi. Okay.
You also went to WebAssembly meetup?
But I don't
Yeah,
know,
the-
I toolkit out, what Flutter is doing? Do they compile to JavaScript and normal web rendering, or do they do
No.
OpenGL?
Yeah, very JavaScript.
Because they already
Yeah.
built that for Angular,
Yeah.
so it makes sense that they use it. And maybe at some point in the future, if they have to improve performance, or if it just makes sense to move it to the WebAssembly direction, maybe they will do it. Or they are planning to do it.
Okay.
They do it for sure. Well, but why not? Yeah, it makes totally sense, but it's cool.
I need to now run this Flutter command.
But you could also run the profile in an emulator, right?
Yes, I could on my Mac. Yes, I could do this. I could run a profile in an emulator, but I want to show the actual device. So what I need to do is actually I need to copy paste this, because of course the plugin doesn't recognize, my plugin isn't configured to run the profile version. Let's see. Okay, DevTools are here. Portal URL. This doesn't actually accept a port, and I'm very angry. And this, because I need to copy the observatory. So whenever you start Dart in either profile or debug mode, it prints out an observatory. The backend profiler is available. I need to copy this into my Dart DevTools to connect and see. There's something happening. And there is something recording even. Now I need to. Doesn't do anything. Oh, pretty. So I did something on my app. You couldn't see that, but you'll see soon enough. And the DevTools let me actually see a little bit what I've done to my mobile. First of all, my little widget tells me I'm way over 16 milliseconds, so it doesn't really go well. And there are 2 threads there. This interface is also a little bit broken. You can see the UI, which is basically your Flutter code running, what it does. And this is a whole frame of your application. It says build, layout, pane, and compose, which is another stage that's more towards assembling an output of different objects. And this takes, well, probably something like 30 milliseconds, so it's already a lot. By the way, if both of these, a GPU thread and UI thread, each take 16 milliseconds, it's still okay if you are not really very keen on responsiveness. So it always will be slightly delayed. Maybe it's not going to be noticed in your app because you don't use like very quick animations, but still, the point is that this should happen actually in 16 milliseconds or less. And it doesn't. You can see it's about 16 milliseconds every time the bar crosses here, so you have several times overdue. Oh, and by the way, most of the time, the UI thread is going to work fine. So fine-ish, let's say much better than the GPU thread. So what you actually do when you have poor practices in developing Flutter apps is you smash the GPU. You just do lots of things that the GPU cannot handle very well, rather than spend lots of time in a UI. So it's more common case that you do some things in a UI that translate to lots of operations in a GPU. And you can see the GPU thread is taking a long time for my application. Okay, so you can, oh my. And if there's like a pink fuchsia color bar here, it means it's way over time. If it's blue, Flutter blue, it means it actually went quite nicely. So out of all the frames that launched for my animation here, only one went into less than 16 milliseconds. And why is that? Is that this application, I'll actually show you now the nicer thing. This application does stupid things. New share. This is my application. And, well, maybe that's going to be even better. It displays a grid of numbers. This is fairly easy. It's 16 fields with numbers. And what you have above, this is called performance overlay, that you can enable in your apps. The top chart is the GPU. Or maybe you can see it actually says GPU over there. And the bottom chart is a UI thread. And whenever you see the red bar, it means that this went way above red bar. It's actually going to, when we have a green bar, it's going to turn red whenever I actually do things above 16 milliseconds. And I need to actually have it this way because it's not designed for landscape. And you see how red it becomes on the GPU thread, right? Almost all the time. So what this app does is basically it has a grid of numbers, 20 numbers. This is not a lot, and it adds a number, then calculates divides it by next prime numbers. So first is basically the count because it divides by 1. The second divides by 2, and it's an integer division, so it goes down. The third one divides by 3. The fourth one divides by 5. And on the right hand side there's also some division, but the point is why it takes so long is that this application actually does set state on a whole thing. So there's one big widget that drives all of this, and it's a stateful widget, and it controls the nice button called next, and it does basically re-render the whole screen over time for the animation. I'm going to switch it to an optimized version, which is maybe not going to be all the time green, but it's going to be green much more frequently. I need to rerun this. That is like an atom. This is the last thing I'm going to show you since I'm over time. I cannot do hot reload in profile mode. Yeah. That was nice, right? I would love it. Hot reload is actually quite a debug function. If you go, it's like separate functions that are there for hot reloading. So. Oh, no, please. So the optimized version of this app, which is going to launch in a moment because of reasons, updates just what needs to get updated, and with actual frames. Running Gradle task. Maybe there will be something better than Gradle that does it like 5 times faster. It's only 7.7 megabytes this app. Okay, here we go again. It's Netflix, what do you have? Jessica Jones. So, and this updates only the fields that actually need to be updated. Please. Okay. So sometimes you can see this bar going on red, but most of the time it's fairly green. And this is a difference that it makes when you actually don't do stupid things. So this was one simple example of the set state. Basically, if you do set state on a bigger object, it's going to go much slower, even if it's simple, basically 20 fields with one big number inside. They don't resize themselves. And if you trim down set state to actually what you need to change, it's going to go much faster. So it's quite easy to shoot yourself in the foot. I'll share the rest of the repo that has some more examples with you through the meetup. Thank you for joining me. Okay, you can have a question.
You showed those statistics on the GPU usage and UI usage for non-optimized app. Can you show the same statistics for the optimized one?
For this one?
Yes.
So it's still going, well, these are going to be the same times, calculated.
Yep.
And these statistics say here, on average, it's 15.6 milliseconds per frame for GPU and 6.3 milliseconds per frame on UI thread.
Ah, okay, so it's essential improvement there as well, okay.
So it's essential?
Essential improvement, because there was something like 88 or so.
Yeah, it was much, actually it was I think twice as much. It was 4 times. No, it was 3 times, 3 frames at least worth. The GPU thread was at least 3 times more expensive on average. Because it, okay. I'm going to finish. Any more questions? I'm still going to be around if you want more questions in private and you don't want to ask right now. Thank you for listening, and come visit Wrocław once in a while. We have Flutter meetups as well. Thanks.